Okay. Good morning, everyone. Glad you made it so early this morning. Glad we made it so early this morning. This session is all about cloud. You might heard it for the first time this word, right? But this session is different. My name is Michael Riefli, or Michael Riefli, or how do you call it in English? I don't know. I'm a cloud architect working at ITnetics in Switzerland, same company as Thomas is working for. We are both dealing with data center management and virtualization stuff, products from Microsoft mainly, and we're building clouds. And this session topic is about we will show you how we are building clouds using the products from ground up until we have a complete stack built on Microsoft Cloud OS, and also the System Center stack on top of that, of course, Windows Azure Pack. So Thomas, you want to introduce yourself?
Yeah, my name is Thomas Maurer. I'm Cloud Architect and Microsoft MVP for Hyper-V. I finally have the chance to work together with Michael here in the same company. As Michael said, we are doing most work we do is building Microsoft Cloud solutions for our customers, and we are both focused on the fabric topics like storage, compute, networking, virtualization, and things like that.
So what will we have on topics today or this morning? We have a long session, so almost, or I would say in the middle of this long session we will take a 10 minutes break. So fortunately we have enough time to show you from ground up how this works, but there is a chance that you fall asleep. So we will make a coffee break in 10 minutes, for 10 minutes in about 40 minutes, and our session will be until 10:45, quarter to 11, I guess. Yeah. So what's the main idea of this session? We want you to have an understanding about the Cloud OS stack from Microsoft. So what it is, all components involved to build a Azure-like private cloud in your data center or in your service provider's data center, wherever. You will hear some deployment experiences. So we already did some cloud projects based on this software stack, and there are some findings, and we will try to keep you up to date with the latest experiences from the field. And of course, we want to have a lot of fun. So if you have questions, please ask questions. We should have enough time to answer them. It should not be a monologue. It should also be a kind of interaction. If you see something which you don't get or don't have a clue what we are talking about, just interrupt us. Thomas, what's the Cloud OS?
Yeah, basically, I think if you have seen any Microsoft presentation in the last year or something, you all have seen this slide. Microsoft talks about the Cloud OS, about a stack where they provide the same technologies in their own data centers, Microsoft Azure, and also for on-premise data centers for customers in their own data centers locally, and also for service providers. This gives Microsoft or the Microsoft stack a huge advantage over other solutions because products are compatible to another, and you can move services or virtual machines from your own cloud, from your own data center into the Azure cloud or to a service provider. You can also move them back to your own cloud if you want to move to it. So that's basically my Cloud OS stack.
Yeah, the basic idea is to have it flexible and to decide where to run your service right now, or in 2 months, or in 2 years.
So to understand the whole concept we are talking about cloud, there are a lot of definitions about cloud. We have a lot of definitions before. So when we talk about cloud, what we mean with cloud is the following 5 scenarios. So first of all, we have this pool of resources or fabric resources: compute, storage, networking, and we want to pool that. That's a big thing we want to do, because we don't want to deploy a virtual machine on exactly that type of vhost. We don't really care. We just want to deploy a virtual machine on our resources. Then we want to make it scalable. So if a customer needs more resources, he shouldn't have to wait until we got new hardware. So we really want to make it a scalable solution. We want to do metering, so we can do chargeback or showback. And we want to make it self-service for for a lot of customers, so they can deploy new services, virtual machines, whatever they want to do by using self-service. And if you want to do self-service, of course, everything has to be automated. So automation is a big keyword here in the whole cloud stack.
Okay, so far we're diving into the first architecture slide. This is how Microsoft Cloud version 2 looks like. On the left side we have Windows Azure. Who in this room did already play around with Windows Azure? Oh, cool. So you might know the portal, how it looks like, you might know which services you can get there. You might have a feeling about the admin experience you get on the Windows Azure platform. Now, if we look on the right side, there is a product or some set of products called Windows Azure Pack. What was it called before? Windows Azure Pack for Windows Server and
Windows Azure Service for Windows Server, I think.
Okay, there were 3 or 4 names until we reached the Windows Azure Pack term. Windows Azure Pack brings self-service portals, admin portals, APIs, which they use on Windows Azure, back to the on-premise cloud. So the main advantage from my point of view is not only to get the services managed as they are managed on Microsoft Azure, it's also a single admin experience and the user experience. So Windows Azure Pack in your own data center looks like Windows Azure in the public cloud. Of course, you don't have all of the services of Windows Azure locally available yet, but there's already some nice things you can do. For example, build your own virtual machines, private clouds using Windows Azure portals, and administrate and manage that in the same experience you have on Windows Azure public platform. Now, I talked about the virtual machine cloud architecture. Thomas,
Yeah,
what we have here on.
We're going to dive in the VM cloud architecture, which basically means infrastructure as a service. There are a lot of other services you can provide with Windows Azure Pack, like website hosting, SQL hosting. We don't going to show that today. We're really looking forward to building Fabric stack as infrastructure as a service. First of all, we have these resources. We have compute, we have storage, and we have network. We have then other service, VMs and other services. And on top of that, we need a solution to manage those Fabric resources. That would be Virtual Machine Manager, which is basically our concept of controlling the Fabric. When we then finally have managed our resources, we have to do self-service, and there is the Windows Azure Pack, the Service Provider Foundation, which is basically the API to Virtual Machine Manager. And then we need some other solutions. We don't just have like 3 products. We need also some WSAS for patching, Windows deployment services, and the RT gateway and things like that.
Yeah, finally, if we have built all this fancy stuff, we have to automate. So it's not a cloud if it's not automated. You won't do anything manually if a user wants to extend his resources, or if you want to provide new services to tenants. So you have to automate. And basically, as you all know, there are products on the market right now from Microsoft, but we will show you a new one, which is also very interesting. Virtual Machine Manager. Let's take a deep dive, or
Yeah, we talked about Virtual Machine Manager as the component which manages our Fabric resources. So if you look what are our Fabric resources, that can be compute with Hyper-V or AS6, VMware, Xen, whatever. We can manage storage. We can use the old school iSCSI fiber channel technologies and storages, or we can use SMB3 file-based storage without or with storage spaces. And we can also manage our network, or starting to manage our network, and do network virtualization, for example. After that, we can manage those resources. We pool them, and that's the concept of clouds. In Virtual Machine Manager, we don't talk about resource pools. We talk about clouds, which are basically the same thing. After we have built those resource pools, we then want to create customers or tenants and give those slices from the clouds. Then they can deploy VMs and services as their resources. As well, again, we have other things which we do with VMM, deployment, automation, monitoring, things like that, or basic monitoring. We can do with virtual machines.
So for example, if you have to spin up 20 new Hyper-V hosts, we use parametric deployment. So we don't do anything manually to spin up a new host, except putting the metal into the rack, connect the out-of-band management cable, and that's it. So parametric deployment is key and is part of Virtual Machine Manager, as Thomas said before.
Let's dive into some of the Fabric topics. We will now talk about storage, compute, network, and after that we will do our little break.
So first of all, storage. From my point of view, the biggest issue to every virtualization project, doesn't matter if it's VDI or not, it doesn't matter if it's only server virtualization, where you have a different type of workloads than VDI, it's always a huge issue. And the issue is mostly defined by having a huge amount of costs for a little amount of resources they really needed. So let's compare a VDI stack with a server virtualization stack. VDI is mostly driven by random writes from each virtual desktop, while a server virtualization workload is more mixed, but it's always the same issue. You're lacking in IOPS. You're not lacking in space. Space is cheap today.
Depends on the solution.
Depends on the solution. But you have to get IOPS. So what can we deliver? I will show you in a minute how that works exactly. We can deliver out of Windows Cloud OS or 2012 R2 server. We can deliver cost-effective storage by using the SMB protocol, by using storage spaces together with JBOD storage, like just have a cheap box, quote cheap, and connect it via redundant SAS cables to a scale-out file server. We have features like auto-tiering. Storage spaces knows two tiers actually, so it's the SSD tier and the HD tier. So we combine the space needs with the performance needs, and what you have to do for that, almost nothing, just put in the SSD drives and the HD drives, create a tiered storage space with the write-back cache. The write-back cache frees you up from random write IOP spikes. So it takes the write random IOP spikes and sucks them in, and then afterwards, when the spike is over, it writes it back to the HD tier. So that's basically how it's working. So how could this look like when we talk about a cloud implementation for a service provider? First, we have those JBoss. Those who already deal with this technology might know that this is a vendor specific model here. It's almost a de facto standard right now. We use them a lot. We put those together. We connect it to a scale-out file server. So basically, two standard HP or IBM or Dell or whatever server nodes. We connect them via multiple SAS cables with multiple lines. So in this case, 4 JBoss connected to 2 file cluster nodes. We have 64 times 6 gigabit shared SAS connection. On top of that, we create the clustered storage spaces. The clustered storage spaces then presents SMB shares, SMB free shares, continuously available SMB free shares. So if one node goes away, we don't have a connection loss or a IOPS loss from the Hyper-V level. And we connect this SMB namespace or the shares we connect via SMB direct. So this is basically how we do it in practice. So we use 10 or 40 gig Ethernet mostly. Rocky technology is, I would say, 3 or 4 out of 5 times we use Rocky. So this Rocky is RDMA over converged Ethernet, and you can go up to 40 gigabytes gigabit Ethernet connections with Mellanox switches, or even other products are possible. So if we scale this stack, we are limited to this. Let's say this solution scales up to, I don't know, 1,000 VMs, 2,000 VMs, doesn't matter. If we need to scale out, we don't put more money in this stack here. We don't try to figure out how can we expand this solution with another JBoss or another 20 Hyper-V hosts. We build a solution which fits the needs for a certain amount of workloads, and then we multiply it. That's the way. That's the concept of a stamp architecture. So far, we are diving now into the RDMA topic. RDMA, as I said, is a technology where you can go up with very high-speed Ethernet connections. The basic functionality behind it is, as you can see in this example, we have a package which flows from the SMB client to the SMB server over Ethernet. We have all the components involved: application client, the TCP transport driver, the NIC driver, the NIC, and then on the other side, of course, the same thing again back into the SMB server. So RDMA now takes off these components. I like to compare it to a server with standard memory, another server with another type of memory, and they are talking on a memory base to each other. So the NIC1 is writing directly to NIC2 over the cable, of course, but without touching the transport and NIC drivers. So we have a huge benefit by increasing the bandwidth we can use for SMB traffic. And also we reduce the overhead, the CPU load on the hosts themselves. This is how you get this fancy 1 million IOP configuration you see on the Microsoft slides. With RDMA, of course. And a lot of SSDs.
What do I need for the RDMA? If I want to do this fancy thing, what do I need?
You need RDMA capable cards. Can be Mellanox, can be something else. You need switches which support your technology you're choosing. You have Rocky, you have InfiniBand, and you have iWork. InfiniBand requires special switches. Rocky is supported on a certain amount of Ethernet switches. You have to get the special cables, SFP plus, or even QSFP for high quality Ethernet for 40 gigabits. You need QSFP cables and JIVICs. Then you need to configure data center bridging on your service. You need to configure priority flow control on your switches if you're using Rocky, for example. So it sounds very complex, but it isn't in fact. So
just the right card,
the right card, the right switches,
at the right setting,
the right cloud architecture. and no, it's not that complex. I would say if you go with iWarp, it's like plug and play. If you go with Rocky, it's like hell on earth if you don't have a checklist what to do. But there are a lot of documentations out right now, so it's not an adventure anymore.
Yeah, 1 year later they have some documentation.
Yes.
Okay.
Well, yeah, Thomas, we have to manage this storage stack, and we don't want to manage each host by himself. So what do we do?
Exactly. So we talked about how Microsoft can do some storage solutions. Of course, there are other storage solutions as the normal SANs we use with Fiber Channel, iSCSI. Then we have this third-party NAS devices which can do SMB3. And of course, as Michael said, we have the scale-out file server and storage spaces solution from Microsoft, which we have to manage. So, Virtual Machine Manager provides a management interface for all those storage types. So we can manage SANs, we can manage scale-up file servers, whatever we need in our environment. Most of the SANs right now you can manage over SMIS provider. So if your SAN vendor does offer you a SMIS provider, and I think most of the common SAN providers do that, you can manage your storage with VMN. I will show you what that means, basically, managing storage with VMN a little bit later. So when you talk about vendors, here's some print screen. This is of course not a list with all the devices, but it shows you, you can see there are a lot of NetApp devices, Hitachi, HP, Dell, whatever.
All this legacy stuff, right?
All this legacy stuff.
Okay, well, I will show you some parts of the storage management in Windows Server. Thomas afterwards will show you the capabilities in VMN for managing the storage.
If internet works.
It does.
I think internet is working. Session always.
Okay. So what we have here
It's blue.
it's blue.
What is doing?
So what we have here is a 2012 R2 server with some disks. As soon as we plug in the disks, they are assigned to a storage pool called Primordial, which is the default container for any physical disk which is plugged in. In a real scenario, of course, we have shared SAS connections to the JBots. So we see from all cluster nodes, we see all the disks, and they are managed by storage spaces or cluster storage spaces. So what we do to create a storage space, we take these disks and we create a new storage pool. This is kind of aggregate the physical disks, write a small amount of metadata to each disk. So there's no volume on it yet, there is nothing configured with redundancy, it's just a aggregation of physical disk resources. Next step is then to create a virtual disk on it, where we define the redundancy. Is it a two-way mirror disk, or a three-way mirror disk, or a parity disk? On top of that, we create a volume, of course, and then a share, and we present it with Hyper-V hosts. Now, I don't want to click that and bother you with a certain amount of clicks, so I created a quick script to create a clustered storage spaces. To prove that I'm not cheating, if I open the failover cluster manager on one of these cluster nodes, I don't have a configured cluster, so it's everything is empty. I don't have a storage pool, I don't have storage spaces, I don't have a cluster. And as we talked about automation, I don't want to click 1,000 times to create this stuff. So we create a new cluster, let's say demo CL01. This is the first node. This is the second node. We have to configure a cluster IP. Then we have to create a name for the soft role, the scale-out file server role, which is a special clustered role on the failover cluster. Soft 01. The storage pool name, demo pool. The virtual disk name, vdisk1. The SSD tier size, I'm going with the 50 gigs SSD size for this demonstration, and 200 gigs hard disk size for the hard disk tier. Write cache size. How big should your write back cache be? 1 gigabyte. There is no recommendation to change that. We could talk for hours why this is like that. The write back cache, as I said, takes the random IOPS from the write spikes and writes it back to the HDD queue. Now imagine if your write back cache is 100 gigabytes. So somewhere, somehow, at some point of time, the storage spaces has to write that data back to the HDD queue. So Microsoft recommends you to leave the 1 gigabyte write back cache as a default. Volume name, VM01. The share name, VM01. Okay, DNS server in my infrastructure, and now this all stuff, the whole stuff is created. It creates a failover cluster. It adds the softs role. It creates a storage pool, the virtual disk, and then it presents it to the cluster storage spaces. The last step I will show you is how can I integrate this storage for my virtual machines in VMM, where Thomas is taking part how to manage storage in VMA.
And of course, you can all do that everything in the UI, but if you want to do it with scale, go with PowerShell. That will basically the answer for everything.
So now even this script I had to put in some manual information. In the real world, we start a run book where we get the information from a configuration management database. Someone wants to create a new cluster, he has to enter some information. All the other stuff is executed behind the scenes by executing automation runbooks. So now, if everything is up and running, I should have a new storage pool. This one with a virtual disk. The virtual disk itself consists of some SSD drives and some HDD drives. It has a tiering, so if I click on properties, I see that there is a SSD tier with 50 gigs and a HDD tier. If I want to increase this now, it's very easy in the GUI, of course. Extend the disk. It calculates the maximum sizes for both of the tiers. And now I'm able to extend it. Let's go with 60 for SSD. Now, the failover cluster, of course, should also have been created. It's there. We have the softs role, the scale-up file server role, which basically provides SMB3 shares. Here's our virtual machine share. Let's take a look if we can access it. Able to access it. The last step would be to integrate this new created scale-out file server in VMM, so we can present it to our Hyper-V clusters. I'm going to the fabric part of VMM, to the storage providers, and I'm going to add the Windows-based file server here. Now it scans the storage provider from the scale-out file server, the Windows storage provider. I add all the resources, the storage pool I created, the cluster storage pool, and also the virtual machine share. And if I want to, I can add some storage classifications. Thomas will tell you more about storage classifications later on. So I go with gold tiered, which is my super duper SSD auto tiering storage, and I finish this step. And to this Hyper-V cluster here, I'm going to add the file share, or I'm going to present. It's a better expression, to present the file share to the server. And here is my soft01 VM01 scale out high available file share. So from that point of view, from that point on, I'm now able to deploy virtual machines to the scale out file server, to the high available SMB3 share with automated storage tiering. So as simple as that. Of course, the real world, some steps are even more automated. I just want to show you how easy it is to create a new storage solution based on the Microsoft OS Cloud Stack. Of course, there are some information you have to be aware if you use storage spaces. I would say the best advice is to not to go for the cheap consumer SSDs. Use the enterprise level single or multi-level cells. Multi-level cells for about 2,000 euros are okay. If your SSD costs about 500 euros, there is something wrong. Why is that? Go to the storage vendor Ask them for the HCL, for SSDs, for storage spaces. So all JBoss vendors have their own HCL for supported SSDs. Respect the HCL, otherwise you will be hit by SSD outages. Storage spaces use a lot of retrim operations to keep the performance up and running, and some of the, I would say, cheap firmware on the SSD drives does not really like a lot of retrim operations. Yeah.
Probably also good to ask us about brands when there's no video camera.
Yeah. Yeah.
Okay, perfect.
So let's go on with storage management in VMM. What we can do here with the other types of storage.
Yeah, basically, I want to show you first VMM. I don't know who in this room is using VMM in production or who has used it before. Okay, yeah, quite a few, but not a lot. So this is the VMM console first, and what you have to get here is you have this different ribbons here, not ribbons, but sections. You have first VMs and services. You have this fabric part, the library part, and jobs. So VMs and services, all the virtual part. We will go into deep dive later on. We have the library part where we store all of our templates, virtual machines, VHDs, and things like that. We have a job view, and we have settings where we can do some basic settings of VMM and do some security stuff as well. So what I want to show you is now the fabric part. So as you can see, we have those three types of fabric parts: servers or compute, networking, and storage. Now, as Michael already showed you, you can attach file servers, you can create or add existing file servers, but what you can also do is you can create new file server clusters directly from VMF. So all the stuff you did, like PowerShell, blah, 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 then you can do that from directly from Virtual Machine Manager. There are some downsides, some features are not integrated, but yeah, we'll talk about that. Then you can add other storage providers. So what I have done here is I have added a scale-up file server cluster like he did, and I added an iSCSI storage device to my environment. So what I can do is I can create simply a new LUN on that iSCSI storage because I connected. I can just say like this is my LUN. Done. Could give them a description and could add some bigger size, but I go with 1 GB now for that. And I create that LUN. That's how easy I can manage storage. So if the virtualization administrator needs more storage, he doesn't have to go to the storage team and ask them, yeah, we need a new LUN, and can you do that please? Most of the time in big enterprise companies, this takes a lot of time. So there will be like a service request or something like that, and then it takes like weeks until you get the new LUN. So if the virtualization admin that can do that, that works perfectly. It's not a lot of companies going for that. There are a lot of storage teams. They say, yeah, we don't want to have the virtualization admin doing anything on our storage, but yeah, you can go for that. So what I see is a lot of service providers going for that approach because they have to be really quick and fast. Most of the time, there are also the same people doing the storage as doing the virtualization, so they're going for that approach. As Michael already showed you, you can also go and create new file shares. I can choose the scale-up file server. I can give that file share a name. Choose one of the classifications. Classifications are basically just tags, so I have to know how I want to tag that storage or that file share, and then I can connect that. So what I do is
those classifications we use later on for VM templates and clouds. So we can assign certain classifications to different tenants. Let's say Sasha is not allowed to use gold tier storage because he doesn't like storage tiering. But another one could be allowed to use all the storage types. Or let's say I have 3 different types of virtual machines I provide to the customers. A huge one, a normal one, and a small one. The small one doesn't use very often a lot of resources, so if a customer is deploying a standard small-sized virtual machine, I want to be sure that it hits a silver tagged storage type. So that's basically the functionality behind those tags we assign for the storage classification.
Yeah, and then finally you have to create the share, and as Michael already showed you, you have to present them to the Hyper-V host. And basically, if you're using SMB as storage, you have to set permissions on the file share. That's everything you have to do. And if you're using VMM in the background, the right permissions get assigned directly on the Hyper-V host. So we go to add, as I already showed you, add file share, choose the share, and connect it.
Are you doing that per host, or can you do that custom-wise?
You can do that if you have a cluster. You can do that cluster-wise.
Okay.
If it's a just standalone host, you do it per host.
But you cannot introduce it to all hosts at once.
If it's standalone hosts, no. If it's clustered, you can.
Yeah, okay.
And if you want to do it with scale, go with PowerShell. That will be done. Okay. Yeah,
That's the answer for everything.
you know. So that was basically to storage management.
As you can see, we have a lot of slides. These only the backup slides if this guy here doesn't work. Network. Am I supposed to talk about network?
Yeah, so that was the first part, storage. Now we're going to talk a little bit about the networking features. We don't have time to cover all of them, of course, but we do it really quickly to talk about them.
Okay, I'll start, and when it gets complicated, you can jump in. Let's talk about service providers, or big companies. What are they confronted with when it comes to networking? So we all know we have those VLAN-based isolation models since decades. We have 40,096 minus 2 virtual LANs we can assign to our network infrastructure. So what if we have 5,000 customers? We are not able to assign more than 4,096 VLANs, so each customer has its own VLAN, its private VLAN, and we are not able to provide more. So we have to isolate the customers from each other. We have to use an isolation method, which is basically VLAN, or it was in the past. We have to isolate the tenants from the physical network infrastructure or the fabric layer. So we don't want customers to get in touch with anything we use on the fabric layer. So we want to separate all the customer traffic from the fabric traffic or from the provider networks. Of course, we want to have self-service capabilities. Bring your own IP address. This is a huge issue if you are a service provider and you want to extend the data centers from your customers to your own location, or enable customers to extend their networks and data centers to your co-location. So this is a huge issue. We have to deal with that. And then we are going for this one. So this is how it should look like. Right?
Yeah, that's like, because why we do the network management, that's one, because we want our data center to look like this and probably not like this. Or like this.
Or this. Okay, so Thomas, we had already logical networking in 2012.
Yeah. So first of all, he was talking about network virtualization or software-defined networking. Who in this room, obviously there are a lot of virtualization guys in there, who in this room has already deployed some software-defined networking stuff in production? Okay. Perfect. Okay, so basically no one, or just a few. So what we do is, in VMM we got this concept where we integrate Microsoft Network Virtualization. So to understand it a little bit more, we have to talk about the words we use in VMM. In VMM 2012, let's go for that. Microsoft introduced the logical networks, network sites, and IP pools. Basically, we use that for our physical network infrastructure. So our logical networks, I basically say that it's our physical network layer. So it's our VLANs, it's our subnets we already have on the physical layer. So if you want to build that, you go to your network administrator and ask him about the list of networks, and you will bring that into VMM. You have network sites to do, if you have different sites, you can do that, manage that. And they have this interesting concept called IP pools. I can see a lot of customers want to use that, but can't, because they have some strange IP address management solution called Excel. So
Just manage the IP addresses using an Excel spreadsheet.
we use all
Don't be ashamed. That's
most of the customers do.
Better question, who doesn't? No one's going to admit it.
Who doesn't?
Who does? Okay, at
Okay.
least two. Okay.
I would be happy if my customers would use Linux Lounge.
There are ways to force them. Delete the spreadsheet.
What an IP pool basically is just a range of IP addresses. And if you deploy a new virtual machine, VMM sees the free IP addresses from that IP pool and can attach one of those IP addresses to that virtual machine. That's it. And the virtual machine gets a fixed IP address until the VM exists. And if the VM is deleted, the IP pool at IP goes back into the pool and is marked as free again. So that's how IP addresses are managed, because no one really wants to care about them. If you're going to deploy a service, you don't really care about the IP address, normally. Okay. So in 2012 R2, Microsoft introduced some new concepts, or in SP1 basically. We still have the logical networks of the physical environment, but now we have VM networks, we have port profiles, and we have the logical switch, which are new. Port profiles, we'll show it a little bit later. There are two kind of port profiles which allow us to, one is the physical uplink port profile, which allows you to define the teaming, the NIC teaming, and the physical part of the IP hosts or scale-up file server host. And we have the virtual port profile, which is basically the port profile for the virtual network adapter of a virtual machine, doing security settings, QoS, bandwidth management, whatever. And then we have this logical switch, which is basically like the distributed switch in VMware. So we have a centralized virtual switch configuration, and we can deploy that to different Hyper-V hosts. So if we change something on the logical switch, it gets set on every Hyper-V host. That's basically the features there.
Let's say you have 100 hosts, or 50 hosts, or 30 hosts, and you want to change the teaming mode from dynamic to Hyper-V port, or vice versa. So you just change the uplink port profile in VMN from Hyper-V port distribution model to dynamic, and then you go to the hosts and choose remediate. So every host will get this configuration change immediately without the need for the administrator to click around on each host and reconfigure NIC teaming. So that's basically the idea, to have a central management for all the networking stuff.
So the next thing I want to talk about is VM networks. So to understand what VM networks are and why we have that, there are not a lot of VMM guys in here. So if you have upgraded from VMM 2012 to 2012 SP1 or to R2, basically what happened was, for each logical network you got a new VM network. That was what happened automatically. And for most people using VLAN, that doesn't really make any sense. They just have another layer now. But if you think about network virtualization, this starts to make sense. So what is network virtualization? It's probably too basic for most of you guys here, but when I talk to customer, I have to explain a little bit on a simple way. And basically I tell them, like, we're now using physical servers, and we do server virtualization on top of that for years now, and we now start to do the same thing for networks. So if you see the concept, in 2012, I told you we had this logical network, which is basically the physical network, and we attach that to a virtual machine. Now, with network virtualization, we can use the same VLAN for different types of virtual networks. So Microsoft introduced the concept of VM networks, and if you're still using VLANs, probably this is a one-to-one mapping. But if you go for network virtualization, you can see that we have still this logical network, which is probably some kind of VLAN. And then we have like multiple virtual networks on top of it. So just to make sure you get the names here right. It was about software-defined networking. I already talked about the logical switch and the port policies we can do with the uplink, the virtual port profiles and things like that. We have not only bandwidth control, we also have the security features like TCP guard and basically things like that. Everything you can do in Hyper-V and the UI you can do with this port profile, which makes it a lot easier. The other thing was, the problem with network virtualization right now, or in the Microsoft stack, was could create those isolated networks, but if you want to go outside the networks, you have to use a gateway solution from a third-party vendor. They weren't really good. I don't know if I think Didier had some experience with that, or no, Damien Flynn. But Microsoft introduced with Windows Server 2012 that you can use a Windows Server virtual machine as a gateway. So basically they use routing and RAS and direct access features to do a gateways connection out of it. Of course, you can cluster this solution. You can use it for VPN, site-to-site VPNs and things like that. So it's made for hosters right now.
That's basically what they use when they enable customers to bring their own IP address. Because you don't want to assign IP address ranges to customers. They should be free to choose which ranges or IP addresses they use. In the meantime, you should not be in charge to manage this, to isolate it from your physical hosting infrastructure. So that's basically what the virtualization does. It's a GRE technique. It's being used for network virtualization. This is a generic routing encapsulation. So each package from a virtual machine is being tagged with a special header from the Hyper-V host, which is being transferred to another host and then being depackaged again. It's a little bit complex, but when we explain it to customers, I often use this term of having a train. So the train is basically the GRE transporting mechanism, and the people which board the train in station A are the packets from the virtual machine. So the people board the train travels from destination A to B, and the people get off from the train to their destination. But that's basically how GRE is working, the virtualization stuff in VMM.
Yeah, you're going to show a little bit about it, right?
Yeah.
Okay, perfect. Next thing is IP address management. Coming back to IP address management, with Windows Server 2012, Microsoft introduced IP address management as a feature in Windows Server, where you could connect Active Directory, DNS, and DHCP servers, and you got all the IP address informations directly from those servers. So this was good for an enterprise company probably, or for some of them, or small companies probably. But it didn't work out really out. It didn't work out for service providers, because there are a lot of networks you don't even have access to it. So they made something clever, because if you're in a highly virtualized environment, VMM knows all the IP addresses of the virtual machines. It knows which network the virtual machine is using and things like that. So it basically got all the information about the IP address management. And now with 2012 R2, we can connect that to our IP address management server. Pretty easy, by the way. And we got all those information directly in our IP address management solution. So I think it's your turn now.
Okay, let's have under the hood of network virtualization. I have a logical network called tenant public. Usually, a virtual machine network has a one-to-one relationship to a logical network, or to a logical network definition. Now, on this logical network, I have different virtual machine networks. So let's take this one. There's a network called LabNet Tom, which must be Tom as the customer and me as the service provider. So if we look here, he has brought his own IP address, which is, or his IP space, which is private range. I don't care if a lot of customers have the same range or not. So because it's tagged with a tenant ID, let's say it like that, it's not really important which IP space the customer brings in with. He can define NAT rules, of course, himself. And if we look under the hood how this works, I'm going to connect to a Hyper-V host. Get net virtualization lookup record. Get net virtualization lookup record prints me out so-called lookup records for GRE. So what does that mean? I have a customer IP address, I have a virtual subnet ID, and I have the provider address. So on this level here, we are on the train level. On this level here, these are the passengers. So each customer IP address gets a provider IP address, which is in charge to transfer the packets from the customer VM1 to customer VM2, because not all the virtual machines are running on one host. So we have to transfer the packages between the hosts without touching the physical network. So each time a user creates a virtual machine on a virtualized network, all the hosts get the virtualization lookup records. Now before VMM 2012 R2, you had to do this manually in PowerShell for each host, for each virtual machine, for each IP address. This wasn't manageable in real world. Since R2, VMM is in charge to do that for you. So it distributes the lookup records to all the Hyper-V hosts. Meaning if VMM is not working, you don't get the lookup records. In fact, the customer won't have connectivity from his virtual machine, which he deployed recently to other virtual machines. So the lookup record is responsible to transfer the packets over the wire to the other virtual machines within the same virtual subnet. We could talk for hours about this. It's fairly complicated if you have to troubleshoot it, but so far it works like a charm now. There were some hotfixes recently, and now I would say it's stable to use it in production. There are some nice to knows. We can talk about that later, but basically this is how the user then the user can bring their own IP addresses. They can extend their networks into your data center by using the VPN site-to-site connections from their data center to the virtual machines on your infrastructure, on the service provider's infrastructure. These are the backup slides, right?
Yeah. So I should show something
why you could show how to create a logical network from
perfect. So you showed a little bit about the physical stuff which happens under the hood. If you have a look at networking in VMM a little bit more, I told you about these logical networks, which are basically the physical network environment. And I just asked my networking guy, which basically was me, about the IP addresses, about the physical IP addresses in my environment. So very simple. And I created those cloud network NVG provider address space. So I had this, I had the word cloud in it, NVGRE, and provider address space. That was important. So this is basically the physical layer where network virtualization happens. Every Hyper-V host gets assigned one of those IP addresses, or even more for local lancing. I just added that to Hyper-V, to the local network. And now, when we're talking about network virtualization, the simple way to do it right now, if you have VMM, you just go and create a new VM network, for example. Tell them customer E2E VC. He uses that logical network, that's provider network. Using isolation, yes, please. And adding my own subnet. So going here, I can choose subnet I want. Okay. Oh.
It's 2.
Yeah, it's still morning for me. If I would use a gateway in my environment, he would ask me now about how I want to connect to the outside world, direct routing, net rules, or site-to-site VPN. So that's the 3 options you have with the gateways. And let me create a network, virtual network, and that's it. So I have a new virtual network, which I can now assign to virtual machines. If I have 2 virtual machines, they can now communicate over that virtualized network. So pretty easy, very, very simple to do. The other thing I want to show you is the setup of this port profiles I talked about, to show you a little bit more about how they look. I have 2 types. I have the virtual type and doubling port profile types. And the virtual port profile is basically the port profile I attach to virtual network adapters, where I can do like performance settings, security settings, or bandwidth control. It's pretty simple. So I can create a port profile for my gold customers, for example, where they have like 1 gigabit of bandwidth, and I can also create a silver where they probably have 100 megabit of bandwidth. So that are basically the virtual port profiles. Then I have this uplink port profiles where I configure the teaming mode, for example, for the Hyper-V host, and also do some which physical network is actually available on that physical network adapter, and I enable network virtualization if I'm still using Windows Server 2012. Told you about fabric management. There are a new concept called network services, where you can attach new services. I already connected IP address management. As you can see, there are other services as well, like gateways, network virtualization gateways, or interesting top-of-the-rack switches. So what we have seen with storage, VMM can manage storage. VMM can also go now and manage network switches. So right now, at the moment in Windows in VMM 2012 R2, you cannot really configure switches, but we can read configuration out of switches. So we can see on which port which VLAN is enabled and which is not. That was one of the things I'll show you. And as you can see, I also connected IP address management. If I look at my IP address management server right now, this is built into server manager. I have here the normal IP address space things, and from my Active Directory DNS server as well. And I have this new virtualized IP address space, which are basically all the networks which VMM can see inside the IP address management. So pretty simple to connect, just a few clicks to do that.
So there's a huge benefit you get out of that. You can, of course, also export this information, but you can see the relationship between the provider stuff and the customer stuff, which wasn't able. You were not able before to do that. Before 2008 R2, there was like a black hole. What's happening and who is using what on the IP address space.
Now we will quickly talk about the Hyper-V, and then I'll do a little break, right?
Let's take 5 minutes for Hyper-V and then make a 10 minutes break.
Quick question on networking. Is there any way to control which subnets can see on another? I mean, ACL rules between subnets.
Basically, customer 1 with subnet A is unable to see customer B with subnet B.
Then I have to rely on my firewalls to allow.
No,
communication on that.
there's no way to connect a tenant with his IP address spaces to another tenant without having traditional routing capabilities, whatever. But if you're using some kind of, let's take an example. You have a virtual machine with 2 virtual NICs. So you create a virtual machine with 2 legs. One leg is in customer address space 1 and the other is in customer or tenant address space 2. You cannot use traditional routing functionalities there. If you do it, so your router or your firewall, whatever, has to understand GRE packages. So this is where it basically stops. So tenants are isolated to each other by default, and from my point of view, there's no way to change that.
You can use direct routing, and then it works with the gateway.
If you use the gateway and direct,
you have to use network virtualization gateway, and you can configure it as direct routing. But in that case, you lose the possibility to have the same subnet for every customer. So you cannot really. You have to have different subnets, otherwise routing doesn't work anymore. That's the key. What you can also do is, if you have a VM network, you can have multiple subnets inside the same VM network, and they are routed automatically.
But fully routed. I mean, cannot control which ports they see between the subnets.
No, there are third-party solutions from. One is from 5.9 software, where you can extend the virtual switch on Hyper-V with firewall management capabilities, where you control which VM with which port can communicate with other VMs on certain ports.
I mean, the use cases for a tenant, I have the DMZ network, I have the production network, the virtual desktops network for the single tenant, but I have to control which ports and which traffic is allowed.
Yeah, I think 5.9 has a solution for that, where they can isolate things and can have like port access or something like that.
So you mean inside a tenant you want to control the traffic from server A to B?
Yeah.
Okay.
And sometimes I have tenants that have to talk to each other through the internal network. Yeah.
Well, it's possible, but as Thomas said, you get drawback when you connect tenants to each other. You bring your own IP address. It's not really the case anymore. There was an interesting survey. Thanks. There was an interesting survey in 2013. What are people thinking about the hypervisors? Hypervisors in public clouds and hypervisors in local data centers or private clouds. Would it be cool if they would be the same product? Yes. So basically that's it, what we have today. Azure runs on Hyper-V, I would say, on a custom build of 2012 R2.
No, that's true.
Let's try another one. If I connect to the virtual machine, you see a pop-up coming up. I can choose which resolution I want to use. I can choose to map local resources like drives or printers into the virtual machine. So this is basically RDP via VM bus. So it's a RDP tunnel connection into the remote connection bus of Hyper-V. So this is cool if you want to troubleshoot or get data in or out of virtual machines. You can enable it by host on the host level. There are other cool features in Hyper-V, of course, in 2012 R2, like the shared VHDX functionality. Who is aware of shared VHDX? Okay, this is basically how to create guest clusters with at least amount of effort. So before we had to use virtual fiber channel, virtual iSCSI to create a guest cluster with a shared disk. So now you can put a VHDX on a scale-out file share or on a cluster shared volume, and you can use it for multiple virtual machines. So a VHDX as a shared cluster disk. Of course, the disk has to be highly available. That's because you have to use a cluster shared volume or a scale-out file share to store it for your guest cluster nodes. So closing with that, we make a 10 minutes break. After this, we will show you the last part, the self-service part and the automation part of this step. Okay, let's meet in 10 minutes.
You get a lot of API layers of a whole framework of accounting, automation, and things like that. And you get two portals. You get the admin portal, which is this one, and you get a tenant portal or a customer portal. So this is the admin portal, and you can see you have different resource providers here. So one is website cloud, VM cloud, SQL Server, and things like that. These are all the offerings you can connect to Windows Azure Pack right now. So what we did here, I connected my VMM stamp or my VMM server. You can have connected multiple VMMs to that, and I can see all the clouds I created in VMM. Like if we switch back to VMM quickly, I'll show you that. You can see I've created some clouds here. Basically what I told you, a cloud is nothing else than a resource pool. So if you have a look at the cloud here, for example, what I can do is assign resources from different host groups inside that cloud. I can also mark physical networks which are available on that cloud and things like that. And I can create customers directly inside VMM or via Windows Azure Pack, which I can assign some resources. Here, create a new customer. To create plans. Plans are basically offerings for your customers. So you can have this VM cloud plan here. And I've said every customer who bought that plan can deploy 10 virtual machines with 10 cores, 10 gigabytes of memory, and things like that. So I can configure basically everything. I can say which VM templates he can use, a lot of more. So
this is the end user experience you're showing right now, right?
yeah. Next thing is the end user portal or the tenant portal. It pretty much looks like the login for Windows Azure. You can customize that, of course, and the end user can log in. And if you have the right certificates, of course, everything works perfectly. Takes a little while to load. Now we have this cool HTML5 portal where he can now manage his virtual machines or create new virtualized networks. Virtual machines take a while to deploy, so I show you a little bit how you can create a new virtual network. Use that and create a new virtual network, custom create. Let's call it E2E web. Could enter DNS. Can define a subnet here. So I will do it again. And I create a virtual network here. What's happening behind the scene is VMM will, Windows Azure Pack will talk to SPF, the Service Provider Foundation API, and the Service Provider Foundation will talk to the VMM and will create, and we'll create that virtual network right here.
There it is.
And I can see here I've created that directly. So this is really powerful if you use network virtualization, and you can give customers the access to create virtual networks. Okay, so that's something we already have deployed. So we have one service provider in Switzerland using that technology, using Windows Azure Pack, using network virtualization, and using the Skyline file server. That's basically what they're using now. And they have some additional stuff in there as well, because we talked a lot about automation. And Michael will tell you a little bit more what you need to do.
So automation, as we heard, is a key component. We want to, with at the least amount of effort, we want to provide the resources to customers. So we have to automate things. The automation stack must be scalable, of course. It must support or use standard APIs. So we want to automate almost everything we can. And that's, of course, based on PowerShell. Actually, what you see here is service management automation architecture. Who is using Orchestrator? 1, 2, 3, 4, 5. Service management automation is part of the Orchestrator install source, install media. But if you have a look at it, it's highly integrated into Windows Azure Pack when it comes to administration. So on this side here, we have the SQL database, which is the heart for storing the runbooks, like Orchestrator stores it in the Orchestrator database. Then we have a OData REST API with a web service portal to create runbooks, to manage them, to launch them, and we have, of course, the runbook workers. They are executing the runbooks really fine. This concept is well known from Orchestrator, more or less, beside the fact that Orchestrator is not really focused on PowerShell, I would say, while SMA is. So I will show you a quick demo of SMA. Oh, there's still on the list. So now again, we are on the admin pack. We are on the admin portal of Windows Azure Pack. As Thomas, I have my VM cloud where I provide the virtual machines. I can provide SQL databases, MySQL databases, websites, 2 tenants, whatever. And on this tab here, we have the automation. So if I click on runbooks, I can see all the runbooks I have created to automate my stuff. Let's say I want to enable a virtual machine for Hyper-V Replica. There must be a runbook which is named Replica. Enable VM replication. Okay. I'm going to kick off that. It asks me some parameters, some are mandatory, some are not. I will say my replica server is the Hyper-V 03. I want to replicate every 30 seconds. I want to keep 4 histories of replicas and an additional 1 for VSS consistency. And the name is, I like to replicate the WAP portal. Why not? Okay. I don't want to wait for the initial sync to kick in. I just want to execute it and then finish the runbook. Now this runbook kicks off a job, similar like in Orchestrator. Job has an instance, and we can see what's happening behind the scenes. Now it's starting. Some seconds later, the runbook worker picks up the runbook and executes what I've defined in the runbook. So this concept is not very new, but the architecture behind it. It's now running, and to prove, and I think it's in the state of receiving the initial replication. Yeah, it's now receiving the initial replication, and this is what my runbook should do: enable a virtual machine for replication. So the runbook has finished. If I want to see more, now if you have used Orchestrator for some years, you may have created your own script repository for PowerShell or .NET script actions because you were not happy with the built-in integration pack actions you have in Orchestrator. So you already created a lot of PowerShell scripts, I guess. If it comes to PowerShell workflows, there is a huge difference. So not every commandlet or every command you can use in native PowerShell scripts is available in workflows. So be aware of that. There are good TechNet articles or blogs from other guys explaining what are the syntactical differences are between native PowerShell scripts and workflows. But at the end, I'm really happy with that. I can edit it in here if I like. So let's say get the process and output that to the console. Very, very sophisticated. I'm going to save the runbook. I'm going to test it. Being executed, I can see the output as soon as it gets kicked off. Now it's running, and if I'm okay with the runbook, I'm going to publish it, and after that it's available for automation. Now, use case. Now let's go back to the presentation. Usually, a question is arising here at this point.
Yeah, we had a lot of discussion here.
A lot of discussions, a lot of rumors, a lot of hates and likes. System Center Orchestrator. It has been there for a while.
It works.
It works. It's, I would say, rock stable. Almost. But sometimes you're limited in features. You really miss. So if you want to execute sophisticated PowerShell code in Orchestrator, you could be pissed off because Orchestrator runs on 32-bit architecture. Now this is SMA. It's brand new. It's it looks very, very sexy, but it has some limitations. You cannot protect credential objects, for example. You cannot choose where the runbook is being executed. So if you have 10 runbook workers, one located in a DM set, especially, we cannot kick off the runbook on a particular runbook worker by defining our source. So this is it's not possible. But you can combine it very well. So you can use Orchestrator and SMA together. You can kick off runbooks on SMA from Orchestrator and vice versa. There is a nice example from another guy from Microsoft who did like a table tennis or ping pong effect. Orchestrator kicks off SMA runbook response, and this is like a ping pong game. And I would say at the moment better together. But what I can feel is that there is a lot of energy put in by Microsoft into SMA. We all do not know how this will continue, but
very nicely said.
Yeah. So
There's one.
that's it. There's
So if you have any questions, I think we just scratched the surface a little bit. We want to show you a little bit of the technologies we use to build a service provider cloud or enterprise cloud. There's a lot of more to it. So if you have any questions, just contact us. If you're here until Sunday, if you bring us beer, probably good. There's another slide.
coffee would be also okay. There's another slide.
Yes. And there's an announcement that System Center Universe Europe 2014 will be in September this year. It will be a cloud and data center managed focused event in Basel, Switzerland. By the way, very nice city because I live there. So, there are a lot of speakers there and focused, as I said, on System Center and Microsoft Cloud Stack, things like that. So the great thing now is you can win a ticket for System Center Universe, which is worth like
$800.
$800.
Yeah.
Okay. So you can now win a ticket, and you have to answer a question, a simple question, which is the protocol used to connect storage to VMM, or most of the time used. What is the provider for that? So you can.
No, you're right.
That's worth.
not fair.
Well, yeah.
Jacob.
Is mine?
There's something missing.
See?
That's right. That's right. Yeah, can you count that? I don't know. Who's the referee of that here?
To connect storage? SMB3?
No, not to connect.
Let's take a look.
Integrating the fabric.
Integrating the fabric, so you can manage from VMM.
So to manage your traditional SAN from VMM, what protocol is used?
Is it C?
Yeah, now you got it.
Okay, so perfect. You can talk to Marcel here.
Yeah.
By the way, if you're interested in more System Center sessions, there will be 2 more sessions about service management and building your own System Center lab. I don't know the times, but
Right now.
Right now.
now.
Okay. So
So thanks for keeping with us.